Hey, welcome to part 2 of revision of the quadratic function. I've got a question for you. Here it is, right here. What's your favourite form for the quadratic function? Is it this one? Okay. Or the factorized form? Or what about expanded form, ax squared plus bx plus c? Which one do you like? If I asked you things about what the graph looked like and things about the function in general, which one's most helpful, do you think? Pause and just think about that. Let's have a look. This one up here is called the vertex form, isn't it? Because we can see, just revising that if you had a set of axes here, and you've got x squared like this is y equals x squared, then x take h squared plus k has moved across this, all points have moved across. Let's say h is positive there, h and up k. So the graph is now over here with a vertex at hk. So that's pretty powerful. What about down here? This one. What's it got to offer? Well, when we put this equal to naught, it's in a factorized form. So with the null factor law, we can find where this function is 0. That's when x take p is naught, or x take q is naught. And so x is p or x is q. What is that giving us when we equate the function to 0? It's where it cuts the x-axis. The x-intercepts will be given by this equation. So come down, let's just draw a little bit of that perhaps. Well, what we've said here is we're now going to be able to say where it cuts here. Okay, and this will be P and Q perhaps. I sort of like this one best because we've got the x-intercepts and halfway between them would be the axis of symmetry, and if we sub that value into the function we'd also have the vertex. Okay, so this factorization, as we call it, is a handy way to go, a handy form to have the quadratic in. And this one over here, the fully expanded form, is quite usual in mathematics when we're working with functions that it will be in the expanded form. We have to actually convert it to these other forms. So this is probably the least helpful, just to look at it. Can you spot in that expression one helpful thing that isn't as obvious in the other two? Okay, do you realise that it is easy to see when x is naught here and here, so that's the y-intercept. The y-intercept is always a number down the end. So it has got its little advantage there as well. It gives you quickly the y-intercept, whereas in the other two forms you have to sub x as naught in. Okay, getting the hang of it here, but we've got to be flexible young mathematicians to be able to move between all these forms and get out of them what we can. Okay, let's have a look at doing that now. So, factorization is taking the expanded form and putting it in a factorized form. It just doesn't always work for all functions. You might have already seen that, and there's another little technique that we can use. And the other way, the other idea is going as an expansion from this side back to this side here. I think that's easier to do, isn't it, to expand the brackets. Factorization is the reverse, so these are actually reverse processes, and that's what this presentation is about, making sure you can get these two forms from each other. And guess what's coming up? Later on we're going to also say, can we write that expanded form in this form here, the vertex form, so that we're fully flexible in what we're doing. Okay, so that might be some further excitement. You've probably seen that before. But let's go on now and have a go at expansions and unpack some of that stuff. So come on down. Here we have some screen clippings here from Hayes and Harris. So let's look at the FOIL rule. That's where you have two brackets multiplied together here, and we've got to remember what it means. It actually means A plus B lots of C plus D. So it's A lots of C plus D plus B lots of C plus D. So it's A by C, A by D, B by C, B by D. Everything in the first bracket must be multiplied by everything in the second bracket. Sometimes called the FOIL rule. This is multiply the firsts together, the outers together, the inners together, and the last together. Just everything, in other words, in one bracket times by everything in the other. Okay, this is very, very important to remember this process, because later on in the presentation we want to go backwards and take an expanded form and put it in a factorized or factored form. So how the terms arise is very important for you to spot as we go through. Now there are some special cases. Look at this one here, difference of two squares. How does this work? A plus B by A take B is the first one squared minus the second one squared. Why did that happen? What happened to the other terms? Let's have a look. A by A is A squared. A by neg B is neg AB. B by A is plus BA. B by neg B is neg B squared. Uh-oh, I see it. AB and BA mean the same thing in maths, don't they? Multiplication is commutative, that's said, is the way we say that. It doesn't matter the order in which we multiply things together, they are equal. And one is negative and one is positive, so they cancel out. So that's how difference of two squares work. Okay, those different signs between the two terms mean they're going to have products which cancel out. Very important idea, that one. Now, this is starting to introduce one of my favourite things in maths, and that is, how do you remember formulas? Or formulae, if you like, the Latin plural. A squared take B squared. It's best not to base your knowledge in A's and B's, but to say that this is of the form first term plus second term by first term minus second term equals first term squared minus second term squared. Okay, get that idea? So you're not basing it just in A's and B's. So if I give you m plus n by m take n, you can easily interpret that as m squared take n squared. So it's a word or generic understanding of the A plus B, A take B formula. Okay, think about that. That's very important in maths. A lot of our formulae are not actually unique. Well, there some are. A circumference of a circle equals pi d, but many other formulas that we use can have various letters in them. They're a generic or family of relationships. Okay, let's look at the perfect square one. That's when the two brackets are the same as each other. A plus B squared or A take B squared. Let's just check the first one. A plus B squared would be A plus B by A plus B. How does it follow this pattern? Let's see here. So A by A is A squared. A by B is AB. Then we get another one of them, BA. Alright, that's the same, plus B squared. Doesn't matter which order you do multiplication in mathematics, it's commutative, it's the same answer. So that's A squared plus 2AB plus B squared. So what we're saying is you can leave this line out if you spot that that's always going to happen. This doubling up of the middle term is always going to happen because you've got an identical product coming from the two brackets here. Okay, so that's a quickie method. Okay, let's go down and practice, and what I want you to try and do is to go straight to the answers in these where there is a pattern. Alright, here we go. Again, screen clipping here from Hayes, and Harris. I'll go through these two examples, and then I want you to have a go at these. Do at least half of them. Okay, here we are. Expand and simplify. Right? 2x by x, 2x squared. 2x by 3, 6x. 1 by x is x. 1 by 3 is 3. Adding up the x's, collecting the like terms, 2x squared plus 7x plus 3. Not too bad. we're using FOIL, this little dude over here. First out is in as last. Do it again. 3x by x, 3x squared. 3x by 3, 9x. Neg 2 by x, neg 2x. Neg 2 by 3, neg 6. Just adding these up, remember 9x take 2x, 7x. Okay, your turn. Have a go. Pause the presentation, have a go, and then toggle forward. I'll show you the answers just underneath here. So there are the answers. So you can toggle back and forward and check your work as you go. All right, let's move on. Let's have a look at one of the pattern ones here. And this time we're going to try and spot first term plus second, first term minus second is first term squared minus second term squared. We're going to try and spot that. Okay, is that one of these? Is this one of those? Yep. First take second, same first plus second. Okay, so we should be able to say it's just the first term squared minus the second term squared. 25x squared, take 4. Over here, first plus second, same first minus second. It follows that form. So it's going to be the first term squared minus the second term squared. Don't forget to square the 2. Okay, have a go. Do all of these because they are quite easy ones. Just notice that root 2 by root 2, squaring root 2 will give you 2. So you can have square roots occurring in there and they'll disappear when you expand. Study that, think about it, get up close and personal with maths, and it's a lot friendly and much more fun that way. Okay, let's go on to the next form. Oh, sorry, here we are, we want the answers. Here we are, we have the answers. Okay, let's go on. Alright, sample 5, using perfect square expansions, these up here. When the two brackets are the same, you're squaring the brackets. And what is it? What would you say here? Let's try and do it generically. First term squared plus twice the product plus second term squared. Now I didn't write that up previously. This is how we should think of it. First term squared plus twice the product of the terms plus second term squared. Okay, so thinking about that in word or generic form. Okay, they always double up. So here in the second one, the product is negative. A times negative B is neg AB, and there's twice the product there. So just think about this form that we're going to always produce, because it's a set pattern if you like. Let's do one over here, x plus 2 squared. First term squared plus twice the product of the two terms x and 2, and second term squared. This is just using the knowledge that the middle terms of the two brackets here will be the same, and you can just do twice them. Okay, 3x take 1 squared. The first term squared, don't forget to square the 3 as well. Twice the product of two terms, 3x by neg 1. So you've got a negative here now. Okay, and then 1 squared. Neg 1 by neg 1 is always, the square on the end will always be positive, won't it? Negative times a negative is a positive. Come down and have a look at these two. So this is perfect square expansion, so look for the form there. And then this one is just a mixed bag. Be careful with the brackets, negatives out the front and things like that. I'd expand the brackets first and then operate with a negative, multiplying the negative through each term. Okay, slightly harder ones there. So just pause presentation, have a go, and the answers are down here. There we have them. Okay, so keep checking, don't do all the problems. Okay, and then find they're all wrong. Check them first. Here's our next bit. Use of brackets we're looking at here. Use of brackets is essential. Okay, well, let's have a look at them because these are a bit more complicated. Over here, 1 take Now, writing the problem out carefully, then use this bracket in here to expand x plus 3 squared. Okay, there it is. First term squared, twice the product, second term squared. And then multiplying through by -2, -2x squared, -12x, and -18. Okay, so if we then put the terms in order, -2x squared, take 12x, -18, but this is a plus 1 here, so it's -17. Okay, just want to be able to do more complicated expressions as you go on in maths. So here, there's a problem, so you can multiply that straight out. That's 2 by 3 is 6, 2 by x is 2x. Then use a bracket here. We want to do this first, but there's a negative out the front, so neg and a square bracket. Okay, so multiplying this out, it's 6, neg 2x, 3x, neg x squared. Then we can collect those up. Well, what they've done here is multiply through by -1 first. Neg 6 plus 2x, take 3x, and plus x squared, doing the negative through there first. You could actually collect these terms up within the bracket if you wanted to do that simplification step before multiplying through by the negative. Okay, now let's collect up the terms. So here, x squared goes first, 2x take 3x, plus 2x. Well, that's actually plus x. Then 6 take 6, 0. So I think you should probably do all of these so you can be skilled in the more complicated ones and with negatives and things floating around. Okay, let's go down and look at the answers to those. Here we are down here. Okay, check them out. Just go back and make sure you've multiplied through the bracket by that term out the front. That's the trick there. Okay, let's go on. And we haven't got far to go now. We're going to go on to factorization. Okay, now factorization is going backwards, isn't it, from what we saw before. We're going to, well, forwards if you're going to the right here, but we're going to take an expression and write it as a product of factors. That means factors are two or more terms multiplied together to give the expression. So we're trying to get these two so that when they are multiplied or expanded like we just did, you will get that original term back again. So you can always check factorization, because expanding you should get the original back. So if you think it's that, expand it and just check it out. Okay, let's have a look at how you do factorizing. Okay, here we are. I've taken this screen clipping here from Hayes and Harris. Okay, you start with the expression. First of all, take out any common factors. Okay, let's do something like 2x squared plus 10x plus 12. What do they mean, take out any common factors? Well, first of all, 2 is a factor of all those. So put it outside the bracket. And then what do you multiply 2 by to get 2x squared? X squared. What do you multiply 2 by to get 10x? It's 5x. What do you multiply 2 by to get 12? It's 6. So we've taken that out for a start. Recognise the type now. Is it a difference of 2 squares? No. Is it a perfect square? We're looking to see this pattern. This is a bit hard to do. This one's okay. If it's a square minus a square, you can spot that. Sometimes these perfect square forms down here are hard to spot, and you'll end up just having to do it in this general way here. So we'll go through that now. Now, you've got to see here that we'll leave this out. You've got to see here that if you're going to try and package this bracket up, the two numbers multiplied together will give 6, won't they? Let's just use reverse of FOIL. So I'll have x and x in there. Just remember where this comes from. How do you get the number down the end? You have these two numbers. So you want the factors of the number down the end. So I'm going to change this. We want the factors of C. This is another way of doing it, but I think we need the factors of C, the number down the end here. We're leaving this as just 1 at the moment. I've just got 1 in there. We'll talk about the harder ones later on. And they've got these two multiply together, but when you do this and this, they have to add to that number there, don't they? So that's what we're going to practice. I'm going to show you how to do that more in more detail in a minute. And then you complete the brackets. Okay, so this is a general one. I'm going to detail this later. I'm just dealing with a 1 in there at the moment. Okay, that's called a monic trinomial. Three terms in here, 3 different powers of x, but with only a one in front here. Okay, and that's what we're talking about in this one down here. Okay, these two must multiply together to give C, and Px, Qx, P plus Q, number of x's must come to B. Okay, let's have a look at each type in turn, and we'll do this one right at the end, and I'll give you a bit more detail on that. Okay, let's go. Here we are, fully factorize. Okay, first thing, is there a number that is common there that will go into both of them? Yes, a number and a letter, 3x, because they've both got a 3 and they've both got an x. Put 3x out the front. What do you multiply 3x by to get 3x squared? You need an x. What do you multiply 3x by to get neg 12x? You need neg 4. Okay, so factorization is closely related to expansions. Just look at this over here. Remember, all factorizations can be checked by expansion. Okay, 4x squared, take 1. Is there a common factor? No. 4 and 1, no common factor. But 4x squared is 2x all squared. Take, and 1 is 1 squared. So it's 2x plus 1, 2x, take 1. The difference of 2 squares rule. You spot that one. Okay, what about this one down here? This is a monic trinomial, if you like, if you want the technical term. But can you see it special? That's a square, and that's a square. And just check, is that twice the product? Yes, well this is the square of x and the square of 6. And this is 2 times x by 6. Okay, and so here it is actually a perfect square form, and it's x take 6 all squared. Now, a lot of people never get the hang of this, so you could do it without spotting the perfect square form. How would you do it? And we'll do this again in a minute. You would say, well, I need 2 brackets, x in front, because I know that factorization is the reverse of expansion, so that'll give me my x squared. What are the 2 numbers in here that I could use to get 36? Could be 36 and 1, 9 and 4, or 6 and 6. Okay, and then you might spot minus and minus, or negative sign in there, then it's a perfect square. So you can go the long way, reversing FOIL if you like, but we'll have a look at some more of those in a minute. Okay, come down. 1C, fully factorise. So remember the steps, take out any common factor, see if they follow a type, and then factorise it. Okay, and these are usually in this batch special types. Can you spot them? Alright, let's go on now and have a look at the answers. Okay, so there are the set of answers for those. I'm just thinking here, of course, got some root 5s in there. Did you spot that? X squared take 5 can be factorised with root 5. Okay, let's go on. Okay, here we are, using the cross method to factorise monic trinomials. So monic trinomials are just where you've got an x squared, something like this, take 2x, take 35. Mono, just 1 in front of x squared there. Okay, so here, this is from Pearson's, this one. This is another method. So start with drawing a pair of crossed arrows. What you're trying to do is, in little shorthand notation, if you like, realise that that's going to be times by that one, and that's going to be times by that one, and these two are going to be times together. So, start off with that. Identify a factor pair for the constant term. So if it's neg 35, how could you get that? It could be neg 35 by 1, okay, or neg 7 by 5, neg 5 by 7, or neg 1 by 35. So they are your four pairs that could go in that. But let's just check this out, make sure you can see that. So it could be x take 35 by x plus 1. We're not going to do all this every time though. X take 1 by x plus 35. Different combos of the possible factors, because these here must always give the neg 35. So that's all you're doing. You're doing the opposite to FOIL. X take 7, x plus 5 is another combo, x take 5, x plus 7. That's what we're trying to check out, all those possibilities. And you could write them out like this if you wanted to. But what we're saying is a shorthand way of writing that is to put the two x's, and then this is multiplied by neg 35 and 1, so that these two here multiply to give the constant down there. We're just checking out combinations. And what now do you want to do? You want to choose, let's take this one here. Let's write this pair out. Neg 7 and 5. So that gives neg 35, that checks. And neg 7 by x would give neg 7x. 5 by x would give plus 5x. So this would be neg 2x, which checks. That's what you want. See, back up here. So you're checking combinations of factors for the n number down here that add up to this. This must be the sum of the factors there. Okay, so this is called sometimes in some textbooks the sum and product rule. You've got the product down the end, and then you've got a sum, the two together in the middle there. Okay, so we've just done this. Select a pair of factors, neg 7 and 5, follow those to write the two terms as a sum or difference. That's what we're doing here, checking it out. And here they have it down here. And so that checks, and therefore it must have been that one. X takes 7 by x plus 5. All we're doing is realising those two multiply together to give neg 35, and have to add up neg 7 plus 5 to give neg 2. Okay, so keep in mind the idea that it's opposite to FOIL. If you know FOIL, where each of those numbers in the expanded expression come from, then you can reverse it. Right, you want to have a go? Let's have a go with some here. Right, so what we're going to do, don't forget to take out a common factor. So here, 3 goes into all of them. So put that out the front. Then what do you multiply 3 by to get 3x squared? You need an x squared. Then 3 times 4x gives 12x. 3 times 3 gives 9. So we then can work on factorising x squared plus 4x plus 3. And notice the note here, the product is 3. So there's only one pair of factors, 3 and 1. So this is an easy one. It's going to be 1 and 3. And do they add up to 4? Yes. Sum is 4, the product is 3. Okay, let's look at this one. Now, generally it's helpful to always, if there's a negative out the front, put that out the front of all the terms. Don't try to work with neg x squared. So if neg is out the front, what do you multiply neg by to get x squared? It's just x squared. What do you multiply negative by in here to get plus 3x? It's neg 3x. What do you multiply negative by to get plus 10? Negative 10. Now the product of the factors is 10, so it could be 10 and 1, or 5 and 2. And because it's negative, you've got to have a negative times a positive, so the one that works is neg 5 and 2. So what you would check here is this. You would say, okay, I could have a 5 and a neg 2 to give neg 10, or I could have, times tables helps here, I could have a negative 5 and a 2. Both of those would give me the right product, neg 10. Which ones work? Which one works? Let's check it. Neg 5x plus 2x is neg 3x, which checks. That's what we've got in the middle here, in that hole there. Okay, so we have negative out the front of x take 5x plus 2. So they are a little bit trickier. So watch those. Always take the negative out of the terms first of all. Oh, all right. have a go. Here we have some. And what's that negative? Let's have a look at the answers. There are our answers. Okay. I'll check these out. It's all out of Hayes, and Harris. Alright, nearly at the end now. Let's have a look at the ones that are a little bit trickier. I haven't used Hayes' method. You can read that in the textbook for yourself. Can you see what's happening here? We've got a different number now in front of x squared. Okay, so what would happen there? Well, let's just check it. To get 2x squared, you must have had 2x by x. Okay, and then you've still got factors of 10 down the end. Alright, so you've got two lots of factors to play with. Okay, the two numbers that multiply together to give 2, and the two numbers multiplied at the end to give 10. So you can do the cross method again, but this time you'll have 2x and try to do a combo. This is a bit harder now because you'll have -5 and 2. Okay, or you could have 2 and -5. But we've got to do all combinations. So here, -5 times 2 is -10, but we could have 2x by 2 is 4x. Take 5x. Oh, that works straight up. That's unfortunate. Okay, see what we're doing there? We're trying to get this middle term. There's two ways of doing it. You could have 2x in one bracket and -5 in another. -10x plus 2x, which would have been -8x. So this is a bit more complicated, looking at the combination of factors in both brackets. So here we're going to have 2x, take 5, and x plus 2. -5 and 2 to give the product down the end is -10. And then just checking these products. -5 by x is -5x, plus 4x gives us the -x in the middle, which checks. Okay, so watch out for that. I don't know whether you want to use this cross method or just use trial and error in the brackets. Let's have a look over at this one. Is there a common factor? Nope. So we have two brackets. Down the end it'll be 14 and 1, or 7 and 2, or could be -14 and -1, -7 and -2, couldn't it? To give that product 14. Unfortunately we've got a 6 here, so this could be 6x and 1x, 3x and 2x. We've got lots of combinations to try. So if you had 3x and 2x, you can start working out the combinations. You could put 7 and 2. That's not going to work. We want a negative sum of terms there, so we could put -7 and -2. That would be -14x. Take 6x. Okay, would that do? No. Let's try again. 3x and 2x. Now it's got to be negative, so let's do here perhaps -2 and -7. So that's -21x. Take 4x. Ooh, that's it, I think. -25x. Okay, so it's a matter of in your brain there how quickly you can do these combinations. So what it means is the 3x is being times by -7, so the -7's in this bracket. Alright, and the 2x is being multiplied by the -2. You've got to keep your wits about you here. That gives -4x and -21x, and -2 by -7 gives +14. So lots of problems here. Got to look at our negatives and positives and so on, as well as multiplication. Okay, and times tables there. Alright, do you feel up to it? Let's have a go. Okay, here they are. Coming to the end of the set now. So, look for a common factor. I don't think there are any here. You might just do a handful of these. These are not going to be important later on. We're going to find a different way of handling the expression without factorising it. But let's see how good you can get here. Right, let's have a look at the answers. Okay, so there are the answers. Have a go and just check out what's going on. And you can always check your answer by expanding it, remember. Factorization is reverse of expansion and vice versa. Alright, a couple of little different ones coming up. And these can be helpful when you're getting bigger expressions in polynomial work later on. Okay, fully factorize all of that. Gee, that's big. And it looks like various parts of it have been factorized. There are 2 factors for the first term and the second term. Okay, so is there a common factor? Can you spot it? Yeah, they've all got an x plus 2 in them. Okay, so this is an unusual type. You put the x plus 2 right out the front. Then how do you get this first term? You need to multiply by 3. How do you get the second term? You need to multiply it by what's missing, which is 2x take 1. How do you get the third term? You need another x plus 2, so that when you multiply all this out, you get this again. Remember, factorization is the reverse of expansion. But keep in mind how it all works, makes it easier. Now, within this bracket here, we can expand this. 3, 2x, take 2. And then neg x, and don't forget this, negative times positive is neg 2. Then collecting up the terms, 3, take 2 is neg 1. 2x take x is x. We usually put the x term first. Okay, so gee, that was interesting. Who would have thought that could come to this? Okay, and that's the value. As you're working with mathematics and the expressions get big, we want the simplest form, so that this is much easier to work with than the unsimplified form there. So go through, see if you can do the same sort of thing, spotting that bigger factor now, that bigger common factor, not just a number and a letter, but maybe a sum of terms as well, x plus 4 or x take 2 and so on. Okay, have a go. I suggest you do all of those and then come down and mark your work. Just down there, the answers. I think we've got one more set to do, and then you're fully qualified as a factorization and expansion person. Okay, let's go down. Okay, here we are. Fully factorise using a difference of 2 squares. So these are slightly bigger ones now. They're giving you a hint though that they can be thought of as difference of 2 squares. So x plus 2 squared take 9. So yes, 9 can be changed to take 3 squared. Okay, take 9, take 3 squared. So it's the first term plus the second. Alright, just like this was a and b. First term, take the second. Okay, and then simplifying it, x plus 5 and x take 1. Adding those two, and 2 take 3 neg 1. What about this one over here? Well, it's already, you can see it's a square minus a square. So what's the pattern? It's the first take the second, first plus the second. It doesn't matter which order you put them in. Okay, you can put the first plus the second is what I usually do first, and that's what they've done over here, and then first take the second. So this term can be put first if you like. Okay, simplifying this, 1 take x, then negative, that's take 2x, take plus 1 is neg 1. And then the same thing in this bracket, 1 take x just comes down, plus 2x plus 1. And then collecting up terms, neg x take 2x is neg 3x, and 1 take 1 disappears, so we've got neg 3x, and over here neg x plus 2x is 1x, and 1 plus 1 is 2. Again, you can see if you want to work on with this function, the value of being able to do that. Working with that rather than the more complicated original difference of squares. Right, I suggest you do all of these. Keep your skill level up. let's have a look at the answers, and then it's cheers from me, and I'll catch you in the next presentation, which, guess what, is getting that vertex form. Okay, x take h squared plus k by completing the square. So we'll revisit that. Let's have a look at the answers now. Okay, mark your work, and I'll catch you a bit later on. Cheers for now.